Lesson 2.1, Integer Exponents. Lesson 2.1, Integer Exponents. Essential question: how can you develop and use the properties of integer exponents? How can you develop and use the properties of integer exponents? Okay, example 1. Simplify each expression. A, 5 minus 2 raised to the 5th power times 3 to the negative 8 plus 5 plus 2 raised to the 0 power. Okay, 5 minus 2 is 3. So now we have 3 to the 5th power. Now bear in mind we're simplifying within parentheses first. So once again, 5 minus 2 is 3. So we ended with 3 to the 5th power. We bring down the 3 to the negative 8. Don't forget that time sign that's in between there. All right, now 5 plus 2, that's 7. So now you have 7 to the 0 power. 5 plus 2 is 7, and then to the 0 power. Now we're going to use our properties of exponents. 3 to the 5th times 3 to the negative 8. We're going to add because our bases are the same. So 5 plus a negative 8 is a negative 3. So we end up with 3 to the negative 3. 7 to the 0 power is equal to 1. Don't forget, anything to the 0 power is always 1. All right, so now we end up with 3 to the negative 3 plus 1. Don't forget, 3 to the negative 3, that can be rewritten as 1 over 3 to the positive 3. 3 to the negative 3 can be rewritten as 1 over 3 to the positive 3. And then we bring along that plus 1. Now, what is 3 to the 3rd? That's equal to 27. So we end up with 1 over 27 plus 1. That's that 1 right there. But don't forget, 3 to the 3rd means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. That's where the 27 came from. So once again, 3 to the negative 3 can be rewritten as 1 over 3 to the positive 3 plus 1. 3 to the 3rd power is equal to 27. 27 plus 1, that's that 1 right there. So now what's 1 over 27 plus 1? That's equal to 1 and 1/27. Okay, let's take a look at example B. We have 3 plus 1 in parentheses raised to the 2nd power, and then that's raised to the 3rd power. 3 plus 1 raised to the 2nd power, and then that is raised to the 3rd power, divided by 7 minus 3 raised to the 2nd power. We do the same thing we did in example A. Simplify within the parentheses. So 3 plus 1 is 4. So now I have 4 to the 2nd power raised to the 3rd power. 3 plus 1 is 4. I bring that 2 down, and I bring that 3. They stay in the same position. So now I got 4 to the 2nd power raised to the 3rd power. I go to the bottom. 7 minus 3 is 4. So that was 7 minus 3 to the 2nd power. So now that means 4 to the 2nd power. I use my properties of exponents. So now I got 4 to the 2nd raised to the 3rd. I automatically know. I just say 2 times 3. What's 2 times 3? 6. And I bring down my 4 to the 2nd. That's already in the bottom. That stays right there. Once again, for a power raised to a power, I multiply. 2 times 3 is 6. So I end up with 4 to the 6th over 4 to the 2nd power. 4 to the 6th divided by 4 to the 2nd. My bases are the same. I'm dividing, so therefore I'm going to subtract. 6 minus 2 is 4. So 4 to the 6th divided by 4 to the 2nd ends up being 4 to the 4th. 4 to the 4th is equal to 256. And don't forget, that means four times 4 times 4 times 4. 4 times 4, that's 16. 16 times 4, that's 64. 64 times 4, that's 256. So once again, 4 times 4 times 4 times 4.
Let's simplify these algebraic expressions as much as possible, and let's just assume, just to avoid having stuff not go right for us, that every unknown we see is definitely not equal to 0. So we don't have to worry about dividing by 0 or anything. Let's take a look at the first one. Here I have negative 3x to the 4th times 4x. Well, the first thing we do is we multiply all the coefficients together. Those are all the actual constant numbers in front of the variables. So I have negative 3 times 4, that's negative 12. And then I have to multiply the x to the 4th by x. And so what's the rule? Well, the x is actually appearing to the invisible 1 power, and when we're multiplying the bases, we add the exponents. And so this equals negative 12 times x to the 5th power, and that's the answer. Imagine x being written out 4 times here, plus this extra time is 5 times, and that's why it's x to the 5th. Pretty cool. How about this one that involves division? Here we have y to the 4th times z divided by y to the 9th, all raised to the 2nd power. First, let's just write this thing in terms of just one person on one line, y to the 4th times z, and I can write this as y, and if I don't want to write a fraction, I could bring this up as a negative 9 exponent. Because remember that the negative 9 means that I take the reciprocal of y, so it's a 1 over y. So now I square that, and what do I see? Well, I can combine the inside stuff first. I have y to the 4th multiplied by y to the negative 9, so I add the exponents. So I have 4 plus negative 9, which is y to the negative 5. And I have that times z squared. And what does a negative 5 power do to the y? I take a reciprocal. And so what I see now is z divided by y to the 5th power, all squared. So that y to the negative 5 is now an over y to the 5. Notice that the negative sign is no longer here because I put it under a divided by sign. So these two things are the same. And now how does that simplify down? Well, if I square the top, I see z squared. If I square the bottom, I see y to the 5th quantity squared. And when I'm raising something to a power and I'm raising that to another power, I multiply. And so I see the exponents are multiplied together, and I see y to the 10th. And so there is a final simplification of this really complicated looking thing. Simplifies down nicely, but there's lots of steps, and those negative signs, those negative signs have to be kept track of really, really carefully. So be careful.